This is the Amp Hour Podcast, recorded December 2nd, 2013, episode 174, Adapting Apraxiated Automobiles.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hello, David. Welcome back to another exciting episode of
Just Us.
the Amp Hour. Duo. The duo. The
Dude,
duo
it's all...
talk that much about electronics.
Yeah. Might not be much electronics today. I don't know.
No,
We'll
we got some.
Yeah, we got some. We've always got some. We always slip in a token amount in there.
Yeah.
You know? Dude, it's all happening here for me.
Yeah, you got tons of stuff going on. Let's hear it.
Well, the first thing this morning, this is a big thing. Analog TV in Australia switched off. That's a big deal for some old pensioners who's still watching analog television.
Yeah, it's a long time coming.
Well, they reckon that some news report said there were 100,000 people in Sydney who still hadn't switched. So I guess there's a lot of pissed off people at 9 a.m. this morning.
Yeah. Oh, the set's out again. Or however you Aussie say it.
Thump on the side. You know?
Yeah, exactly.
The idiot box has gone on the blink, you know.
Yeah.
Yeah.
So do you
picture...
know, I guess you said that, how many people that affects, but that doesn't affect you though, right? I mean,
No, I've been digital TV since it started in 2001. So,
yeah.
I think I started a month after it. I went out and bought a digital set-top box and never looked back, really. I had a lot of fight with it, though. This is all pre the blog. I used to put all this stuff on the news groups and, other forums that I was on at the time bitching about, along with everyone else, because the early digital TV receivers were pretty flaky, in terms of firmware and stuff like that. Oh, yeah. You had to buy the right type of, the right brand of box, and you had to have the right version of firmware in there, and then it might stay up and running for a couple of days. It was all pretty dodgy back then. And, my main fear was back then of, buying a TV, which was a premium at the time that had a built-in digital tuner. I still don't own a TV with a built-in digital tuner. Mine are analog TVs, and I've got external digital set-top boxes.
Really?
Yeah, because you paid a premium, up
still?
until...
You
okay,
do?
Yeah, well, no, not anymore, of course, but, I bought my last TV maybe 5 years ago, It was still a very premium price back then, for a built-in digital set-top box. And my fear was, oh, no, it's built in, you can't upgrade the firmware, it's all just shit, and it's, And, of course, they've ironed out those issues now, and I don't think there's too many complaints these days, but digital was really an issue. If you had like an old analog antenna, right, in quote marks,
Bunny
ears. Designed for the analog frequencies, because the digital frequencies changed, of course, and the modern type of antenna is the log periodic type of antenna, which the log periodic arrangement of the elements. That's what it's called for all you antenna RF freaks out there who know what I'm talking about. And of course the coax, the loss in the coax and stuff like that was a big deal. So if you had, your old analog TV, you ran through, crappy, barely shielded, 10% shielded coax or something, over a long run it didn't really work. So a lot of people like me had to upgrade our coax to, quad shielded, RG, 9 or whatever it was. I can't remember the exact type, but it was a big deal. And you get lots of interference, I still get interference. If our roller door goes down in our up or down in our garage, the digital TV cuts out.
Really? Wow. That's not very good design.
No. Well, that's that's how it works. That's the nature of it. It's sort of that all or nothing thing. Whereas analog TV, you can get some lines on the screen, or you'd get some, static or interference, but it'd still come through. The audio would still come through, but digital, when it loses it, X number of frames, it just cuts out.
Yeah, mine does that too. It says like 2 week of signal or something like that, and it just
and then it takes a couple of frames to recover itself for the algorithm to recover and start again, and it's and you get these large audio pop noises. So when the badly designed firmware again, so when the roller door goes up, it's like coming from the bloody TV. It's really annoying. And as Murphy has it, it's right at the critical point you're trying to listen to something important. Yep.
What do you mean the amp hour's not on TV yet? Sorry, that was terrible.
Anyway, I've uploaded the video, and it did switch off. Sure enough, somebody somewhere flicked a switch, or more likely didn't flick a switch. They more likely, put a command
big old
into
knife
a computer.
Switch with like
big
turn off a huge power plant, powering the entire thing, right?
And that power down noise,
Right.
And and sure enough, it went to static. They had a little dancey broadcast animated thing, and then counting down, bye bye, and then static. Yeah.
It's interesting. I was reading about. I think they said they're going to try and they might repurpose some of that what's now white space, I guess.
Right.
And I think
the spectrum you're talking about.
Yeah, like auction it off because it's now there's a significant
of course
portion of section or of spectrum that's now available. So
I'm not sure what they're doing with the Australian spectrum there. I'm not sure. There's
a lot of politics involved with that stuff. A lot of money in politics with spectrum, especially if it's usable for cell phone commercial type stuff. They can really,
Yeah, but there's suddenly a big smack of spectrum available in various parts. Yeah, I think ours are around the 170 megahertz or something like that. I don't know about you guys, but there's a spread. And it just occurred to me after I recorded the thing, I should have had my spectrum analyzer hooked up and I could have actually seen the carrier disappear. That would have been cool.
That would have been cool,
it just didn't occur to me.
Yeah. Oh, well. You'll get it next time, don't worry.
So do you Yanks still have analog TV?
No, I was actually just looking at the wiki page about the shut-off, but at least in my area it's all gone, and I'm pretty sure it's gone everywhere. I think I remember it because I think Paul Rako wrote about it when he was still at EDN. He was writing about the switch over, and I think he might have been writing about the Spectrum as well. But yeah, it's definitely gone here. So, it says Friday, June 26, 2009. So.
Oh, okay.
Or, no, that's Nightline. I don't know.
Yeah. So we're one of the few hanger-oners, are we?
Yeah. No, there's a bunch more.
Right.
Looks like it says 2015 is the absolute shutdown for LPTV local stations. So there might be some hangers-oners here too, but whatever. It's not like people running out and buying old sets. It is kind of a weird, it's an end of an era though, because it's you could have still fixed up your old tube TV. You could have still, built kits that could have done it without DSP and all that kind of stuff. But I don't know I don't think that's really possible with digital TV now. So it's kind of a...
Well, you can feed shit in via the HDMI input.
Yeah, but that's a little less tubey, tinkery kind of,
Yeah, it's not quite the same, is it?
Yeah, right.
But hey, you can get it full high definition, digital clarity.
Yeah, whatever. So what else is going on other than TV? We don't watch TV anyways, right? We're building circuit boards and stuff like that, or buying crazy stuff on eBay.
eBay. I am now. Well, I will be once I pick it up. The proud owner of a Sinclair C5.
Also known to the layman as a Nerdmobile.
Nerdmobile. I'll have one of the few in the country. It's a bit of a fixer-upper, but apparently it runs. I need to get a battery for it and needs a good clean by the looks of the eBay photos. But I scored one. I was the only bidder. I was shocked.
Now you need to pimp it out with a... Well, you said maybe you could put reverse into it, right? Because
it doesn't reverse. I'd love to be able to drive it into the lift of my building here and then go up, but then I can't get out of the lift because there's no reverse gear on the bloody thing,
And, yeah, man. Well, maybe you could start doing mechanical stuff as well. I don't know.
Yeah. Although the wife doesn't let me, won't let me keep it at home, so. You're not bringing
not
that
a surprising
heap of shit
decision
home.
there. Yeah, not a surprising decision.
Yeah, so I'm going to have to put it up on blocks here in the lab. Yep.
Yeah. Very tiny, wimpy blocks. I know. No, that's a good find. I mean, if you're into that kind of thing, I'm sure you could find. I mean, you said Malcolm already has that, right? Was it Malcolm or someone else?
Mal's got one. No, two. Yeah, he's got two. Well, technically, one's his, one is someone else's that he knows. But
right.
Yeah, I mean, I don't think there's too many of these in the country. So just from a historical point of view, these things are, they're so cult following.
If you park it on the street, you're not technically keeping it at home. You're just using it as a transportation device to and from work.
Right. Although I live in the hills district and, it doesn't go up hills, Lots of pedal assistance required.
If you soup it up, you might be able to. You never know, man.
Yeah, right.
There's a project. Put some actual tires on it, soup it up.
Right.
Pimp my nerd ride.
Yep. Yeah. No, I'll be getting into the whole thing. I'll probably be joining the Sinclair Users Forum, Sinclair Enthusiast Forum, yeah.
Yes. That's the important stuff, right?
Exactly.
Couldn't have done that before.
Hanging out with the other nerds,
Yeah.
Well, that's what it's all about, there's not many people who own one of these suckers.
I imagine you guys
if you may.
I imagine if you guys rolling into a classic car show in one of those things and be like, "What? It's a classic."
Well, see, that's what I can do. I can turn up to the electric car shows and things. Woohoo, drive it in and yep, it'd be fantastic.
Oh man, pull into a Tesla supercharger station and be like,
right,
fill her up, please. Endless nerd jokes.
Yeah. Well, you said about upgrading. I'm kind of torn. It's like, do you keep the original thing or do you soup it up, and actually make it usable to go up hills and make it go in reverse and, practical stuff, or do you sort of keep that, the original retro thing?
What's the original thing? Why would you want to do that?
Well, the original motor, everything's original, it's original condition kind of thing.
For resale though? I mean, I never understood that mindset.
Just for the sake of it being an original unit. It's
I am not a collector, obviously.
It's kind of like buying it's like buying an old tech scope and ripping out the guts and replacing it with modern stuff, or or restoring vintage valve radios and replace them with transistors.
I wouldn't think it's like that. I would think it'd be more like replacing. Well, maybe. I guess it's not really repair, but you can do small upgrades here and there.
Well, you can, yeah. It's like, like a lot of the vintage tube radio enthusiasts, they replace, caps are a major thing. So they will replace, the old paper capacitors with, modern caps and stuff like that, but they'll still use the valves. And, a lot of them, there's a whole, there's a section of the enthusiast industry that, they rip out all the guts, but they keep the look and feel of it. Is fine, but you can do whatever you want inside. Anything goes. And that could be the case here. To make it more practical, I could, rip out the motor and replace it all and put decent wheels on it and, but as long as it still looks the same on the outside, I guess that's what counts.
Yeah, man. Well, I think the upgrades are more fun, personally, so. Plus, we could talk motors then, too.
Yeah, no, totally. Yeah, exactly. Are we able to put a poll? Can we put a poll on the...
A poll? To ask what you should do?
And to ask what people, what do you think? Should I keep it in original? Is original condition more important, or should I make it practical underneath in terms of upgrading the motor? And
well, how about we put that over on the EEV blog forum? Because then there's the poll, there's the poll thing there, and then people can discuss it as well.
Okay, yeah, I'll do that. All right, poll coming up, folks.
We'll put it on we can put it on the amp hour section, or if you want, you put it where. I don't care where you put it, but yeah. Yeah, but we could talk motors then too. I'm getting into motors.
Why are you getting into motors?
Well, so I talked about it in the past, the AC induction stuff. But I finally got a kit for it. I got a dev kit, and this thing is a monster. It's
as a dev kit, you actually get a motor.
Yeah, exactly. So, there's two parts to it. There's the board, and then there's a separate motor that they suggest. But it's a NEMA 48. I think NEMA 48 bracket.
Oh, they're used in the quadcopters, I think, aren't they?
No, no, no.
No?
The NEMA 48's about the size of a football. American football.
Right.
It's big. I mean,
Right.
it's like big.
Right.
It's much bigger than I thought it would be. Actually, it's only a quarter horsepower,
And
but that's
Chris is feeling very manly right about now, folks.
I'm scared of everything in this is very scary.
You're scared
actually,
of it. Right.
Yeah. So a quarter horsepower is 180 watts, which isn't much, but I think the bracket, the NEMA. Actually, I never realized because I have NEMA 23. Brackets on my stepper motors for my mill.
Right.
And those are stepper motors, so they basically send out pulses, and basically one pulse is one little crank onto the gear, basically, and that's how much it moves. But the NEMA refers to the size of the bracket, and a lot of like the MakerBot uses, I think, NEMA 17s. I'm not sure.
Yeah, that
like those kind of stepper motors. Yeah. So this is a 48. So it's bigger. But this is not stepper motor. This is AC induction. But then there's also brushless DC and everything else. Right. So that's one part of the kit. There's like motor. It's not really part of the kit itself, but it's the motor that we bought. And then the kit though. So I got a kit from TI, a TMS. I'm looking at it right now. It's a huge box. TMS.
But it's not really a kit, is it? It's build up board.
Yeah, sorry. Yeah, it's a development. It's a development platform, really.
Right.
The TMS 320 C2000. It's
so it's actually got a DSP on it.
Is that C2000 is a micro? It's not a DSP, I think.
Oh well, you said TMS 320, which is a DSP.
Is it? See, that's how
which is a Texas Instruments DSP. Yeah.
Yeah. Okay. Yeah. Still getting into
but
it.
It's got some powerful computing on it, right?
Yeah.
And what's all this computing for?
That's not the scary thing. Well, because that's the thing. Like, so I talked about, I marveled at the past because I didn't really say much about it. And like I said, I'm still learning a lot about it. But all of this stuff, it's like there's so many like algorithms and stuff like that because it can basically, you measure the different. It's a 3-phase, so it measures the different voltages and currents and stuff like that, and then basically it can infer position from that. And there's like all this crazy ass vector math in there, and all these translation algorithms. Like I think it's a Park transform, and there's like a bunch of different transforms in there, and so it can actually intuit or calculate rather the position of how far it's turned and stuff like that, and how fast it's moving and torque and yada yada yada, and then eventually
does it read back the signal as well, so that it can actually read the position and stuff like that, and infer the position from the EMF feedback or something like that?
Yeah, there's two things. So you can actually stick a encoder on there. An encoder will actually tell you the absolute position, right?
Oh, of course, right.
Yeah, that's how much it spins. Yeah. But then, there's these other algorithms that tell you position based on calculation. But that's not even the coolest part about this kit. This kit is actually it's an offline. So basically, it takes wall power, right? In this case, 120 around here.
Well,
single
you said
phase.
you said it's 3-phase though.
Well, that's the crazy thing. Takes wall power and it does power factor correction on that. 120 volts to 350 volt DC bus.
DC, and then converts it to 3-phase AC.
And then it has an inverter, a 3-phase inverter. And like looking at this thing, you got to look at it. I got to see if I can find a picture of it. It is like, I mean, it's about.
Yeah, I was going to say this has got to be a big board, right? It's like size of an A4 sheet or something.
It's like 1.5 feet across.
I was going to say,
so like half a meter across, and then probably about a third of a meter deep.
Half a meter?
Half a
Dude,
meter.
what are you talking about? Half a meter is 500 millimeters.
That's 1.5 feet, isn't it? Half a meter?
No, well, a foot's only 300 millimeters. 1.5 feet would be 450. Okay, it'd be almost, Yeah,
it's almost 18 inches across. Yeah, it's huge. I'm telling you, it's huge. Anyway, so this is just one of the platforms out there. I got the TI. It's a TI one, but there's a bunch of people have this stuff. And the thing I didn't realize is it's such big money into this. I mean, like, so basically what this does is it basically creates you can just plug any of these AC induction motors into the wall with 3-phase power, and it'll just fire
it'll
on.
just spin, right? Yeah.
But now you can basically control those different phases and change the speed, change the torque, all this other stuff. Do dynamic.
And what would these things be? What would be the typical end application for these 3-phase induction motors powered from all this wizardry?
So like a lot of them are like industrial drives are the big ones. So you might be running like a big pump or
Yeah, but a pump just goes on, off, right? On.
Right,
off.
but a lot of this is power saving as well. So basically, you can,
right.
instead of like having, so this is like a variable frequency drive is what the entire unit's really called, a VFD.
Yep.
And basically by changing the frequency, you change the overall power usage, and you can change the torque and all these other things that I don't understand yet. But basically the idea is you can save a lot of power over just having a big switch that you ka-chunk on, ka-chunk off.
Right.
And then the other really cool thing is that, you can, because it's dynamic, right? Like if you look at like how a Tesla Model X, the Model S works or something like that, they're doing a very similar kind of thing where they don't have an offline power factor corrected circuit that powers the DC bus, but they have a big battery bank that sits there and does the same kind of thing. And so they charge the bank, they discharge the bank through this inverter, back and forth, back and forth, back and forth.
And they're using 3-phase induction motors, are they, on the Tesla?
I'm pretty sure. I could be wrong about that, but
right.
I think so, just because I remember being shocked when I heard that at first.
Right.
That's basically what I'm going off of here. Yeah, but I know for like regenerative braking, that's a lot of the stuff. So
okay.
Yeah, so exciting stuff, but I am terrified. I mean, so
why
I've worked
did you
with high
get this
voltage
thing?
For a project I'm working on with a friend.
Right, okay.
Yeah, it's
because you don't have enough
about it.
stuff on your plate.
No, definitely not. This is a really good one, though. I'll tell you after the show. It's a very good cause.
I know, and you don't, guys.
Yeah, and I know secrets about Dave too.
Right, yeah.
Yeah. But anyways, the kit itself is beautiful. I mean, it was like $700. It was insane.
Oh, I was going to say,
like,
it wouldn't. It sounds like it wouldn't have been cheap. Does that include the motor, or is that just the board?
No, the motor's another $300. So that's
wow, $1,000 for just to play around. But
I did not pay for it.
This is serious, right? No, this is not hobbyist stuff, right? This is not hobbyist.
No, this is not. And if you look at these are some big IGBTs on the board. I mean, this is a lot of.
No, they're very expensive.
This is some high-end stuff. It's very nice.
Yep.
And like you said, actually, the thing I really like about it is that the board, the control board, is it's a C2000 Piccolo, whatever, and then it might have a DSP, like I said, but it's all on like a so dim, like the memory style slots.
Yeah.
So they repurpose those, and basically they're replaceable for when I blow them up.
Right. When, not if. Yeah.
Yeah. Right. Well, that's what I'm really worried about. Is like I haven't had. I've done high voltage stuff before, but it's always been in a work context. I've never had this high a voltage at home before, and so I'm a little trepidatious about it. But
right,
I'll get over it.
Yep.
Yeah,
sounds like fun.
But I don't know. But I mean, I think about this stuff too. I mean, this is not the purpose of it, but I think about it from like a. Say like I had, say you have solar panels in your house, right? So say you had like a storage grid then, right? You had a storage, maybe you had a 350 volt stack in your house, right? Well, this kind of kit or this kind of application is the first time I've ever been like, oh, you can actually take that and make it something useful again. Like you could run a compressor on a fridge, right? I mean, that's effectively a compressor is just a motor. I mean, on the back, and so you could run a fridge off of this kind of thing. You could make smaller versions of this kind of kit and make a whole bunch of DC accessible equipment for a DC powered home. I mean, like it's kind of the first time it all snapped together in my head, and I knew it was possible somehow. I just didn't know what. And but like a lot of this inverter technology and stuff like that makes it more possible. Obviously, there's commercial inverters as well because you feed back to the grid with that kind of thing. But yeah, I don't know. It just never really clicked for me.
Brilliant. Can we expect to see some videos on this?
I hope so. Yeah, I have a video. We were cutting a mounting bracket on my mill for the motor. I still need to edit that, but that might be up eventually. And yeah, obviously the electronics as well.
Well, obviously. That's what people are interested in.
Not all they're interested in.
It's an electronics podcast.
Hey, you know what? You have to be an everyman these days in order to
you do.
You need to be able to do everything. You can't just do electronics. You can't just do hardware. You have to do software as well. You have to be a purchasing agent these days.
Yeah,
be a mechanical engineer, right? I mean, like
yep,
it's everything.
Do all those 3D CAD models for your 3D printer.
Exactly. You've been doing that.
Well, which you can probably only buy from MakerBot in the near future.
Oh, yes. Stupid lawsuits. And you have to be a lawyer these days because you have to deal with...
If you haven't...
Yeah, go ahead.
Well, I don't know. What do you have to deal with before I start my rant?
I was going to say licensing. I mean, whatever comes out of this crap, I mean, it's going to be something soon, but I don't know. It's just, this is all lawyery.
Yeah, this is just
BS.
Bullshit, folks. If you haven't heard, Stratasys, who bought MakerBot, right? They're a huge industrial 3D printer company, and they've decided to sue Affinia, which is a small American company, I believe, who sell the Up 3D printer, right? I think, it's not their printer, it's Up's printer, but they've decided to sue them based on some patents for various software algorithms or something like that they've had for like 20 years. And Stratasys, bunch of dickheads, have sat by for 20 years, let the whole 3D desktop printer industry build up, not saying a word, not threatening anyone, and then all of a sudden we buy MakerBot, and as soon as the deal is signed and gone through, boom, we're going to sue everyone.
Right.
Well, they've only sued Affinia first of all.
Right.
But
the ones with viable products, right?
Yeah.
They're not going after like an Ultimaker, like somewhat like the smaller hobbyist stuff right now.
Not yet. But see, that's the thing. This is a strategic play, and it's obviously a strategic play to dominate the desktop 3D market. That's why they overpaid for freaking, they paid a ridiculous amount for MakerBot, and everyone knows it. And this is the way that they're going to justify it, by either shutting down the rest of the industry or scaring them into licensing fees.
Yep.
And it's a strategic move because they haven't gone after the biggest competitor to MakerBot. They've gone after like a mid-level player, right, but still a decent name. That Up printer is one of the most popular printers out there, but in terms of competition, they're not the biggest, and they've deliberately gone after them. Why? Because it's obvious they don't have the money to defend a patent lawsuit, right? So what's going to happen? They'll have to either find a company that would take on a couple of $1 million case for gratis. Which doesn't happen very often, or they would just have to fold the company, or they'd have to settle and pay a licensing fee if that's what Stratasys want to happen, which, is likely. And then once that happens, that's why they targeted this mid-level player, because they know they can't defend this lawsuit, so they're going to have to cave in one way or another, and then that sets a precedent for everyone else in the industry, and, oh, look, Affinia got sued, oh, shit, we're next, And everyone runs scared shitless of the big bully in the industry now, Stratasys. Bunch of assholes.
Yeah.
End rant.
Yeah. Well, this is, so the Affinia is the so that's different than the other big company is 3D Systems, right? That would be the other big player.
Yeah, 3D, another big player.
But if I think I saw it's the infill, which is what they actually patented, right?
There's a couple of things, yeah. There's the infill, like, the 10% infill, plus the sort of an algorithm, I think, of rounding the corners or you're rounding overlaps or something like that. I don't think anyone's really gone in and analysed to see if these patents are even valid or whether or not it's a valid claim yet. But as everyone knows in the patent world, that doesn't matter. Whether or not it's a valid patent lawsuit makes absolutely no difference whatsoever. Affinia still have to defend it. And to defend it will cost millions of dollars, which they most likely don't have.
Yeah. Yeah, it's so dumb.
So,
I mean,
yeah, I know.
It's like you have to stay a certain size, right? Like, that's the ultimate thing, is you can't get too big, or else everybody comes gunning for you.
You'll be on the grid, right? Yeah.
Yep.
And if you,
and then all the lawyers come out.
Yeah, it's just, I know. It's bullshit.
Yeah.
So, oh man, this is bad for the desktop 3D printing industry, which is just, hitting mainstream now. And bloody hell.
Yeah. Well, and I think it was Stratasys that went after, I think they're still going after, what's her name, the Form 1 for the SLA printing as well.
That was 3D Systems, actually.
Oh, that was 3D Systems going after
that. Was 3D Systems, I believe, who got the licensing fee out of, which that patent's now expired, apparently. So they were like a year too early. So I think now anyone can do the laser sintering thing without violating 3D Systems patent or something like that. Don't quote me on that, but I think that's the case. So there you go. Bastards.
Stupid lawyers.
I know.
Stupid executives. That's why we stay small, right, Dave?
That's it. Yep.
That's the one.
Off
That's
the grid.
The one. Yeah. Speaking of small companies and ones that probably are using 3D printers too, there's actually a new seminar series, which is actually kind of interesting. I don't know if you saw this thing, the Hardware Workshop. Did you hear about that?
No, I haven't seen it.
Yeah, so it was started by where is he? Mark Barros, who started Contour Cameras. But basically, it's an application process, but it's actually this coming weekend in New York, the 6th and 7th. And there's actually some familiar faces there, too. So Scott Miller, who's been on the show
Scott
here.
Miller's there, yep.
Yeah, he's going to give some talks. Some of the guys from Lemnos Labs. I mean, a lot of the hardware startup companies, Dropcam, Siftio. A lot of the ones we've heard of in the past, but also, the ones who have some good experience, too. And obviously Scott having a lot of experience over in China with high volume production. There's a guy from Flextronics, which is a huge that's a huge CM over there too. So
yep.
Yeah, and looks like a cool program. Looks like it's not going to be stopping anytime soon. There's already one in San Francisco. There's another coming up in Seattle.
These programs seem to be jumping up everywhere. I'm always hearing about, these, Kickstarter hardware startup workshops or,
meetups. There's a lot of
funding meetups, and there's tons of them.
There's a lot of interest. Yeah, it's
crazy.
I don't know where it's all going to go.
Every man and his dog. Well, every man and his dog's doing a hardware startup these days. It used to be software. Now it's bloody hardware.
Yeah, well, I think we talked about that a while back, too. And, I was worried about it becoming a little, what's the word? Shammy?
Saturated?
Yeah, saturated is a better word. I guess the thing that kind of starts to bug me about it, too, is, all of this stuff is really tiny, and so I think that's why I'm getting more interested in the bigger stuff as well. Not to be a contrarian,
tiny in
but
what way?
Well, this little thing talks to a cell phone. Oh, this other little thing talks to a cell phone. Oh, this little thing talks to a cell phone.
Oh, you're trying,
right.
It's just everyone's
accessible
doing a
stuff.
Startup based on one little gadget.
Right. And it's basically. I mean, you should say it for what it is, right? I mean, it's really hardware is just a way for these kind of companies. A lot of it is hardware is a peek into a marketplace, right? So you might have something that outputs data
or it's
to an
a
app.
business building thing.
Yeah, exactly. And then you can sell the data to people.
Well, that's the problem, isn't it? People are, but people are thinking, it's a way to get rich to build up a business. To me, I never think like that. I don't want to build up a business. I just, I got an idea. Okay, I might put it on Kickstarter or something. But my idea is to produce the product rather than build up a business.
Yeah.
It's sort of like a one-off kind of thing.
Yeah,
but there's so many people out there who go in with the mentality of, we're going to do a startup to build a company, rather than to just focus on the product. The product's just almost, it doesn't matter.
Inconsequential.
It's just a way. Yeah, it's inconsequential. It's just a way to start up the company.
Huh. That's an interesting way to think about it too, because it's good to have that focus on the product as well, because that's probably what's most important, especially with hardware, right? There's nothing else really there. You might have a community behind it, but it's like if the product's crap, then who cares? Yeah, that's interesting. I mean, I keep seeing these articles about it though too. We didn't understand everything that went into it, and I don't think I know everything that goes into manufacturing, because I am continually in
there's
shock
always
and
something
awe.
to learn about manufacturing.
Yeah, there's always crap. But there's a post about that that actually kind of fits in with your recent video about testing. There was one from Pinocchio, if people remember that one. It was basically a mesh network, kind of like a dongle that kind of you could hook anything to it for mesh networking. It's kind of like an Arduino plus a wire. I don't know if it's Wi-Fi or if it's Bluetooth or something like that. I know it's Wi-Fi, but then basically it creates mesh networks through a software layer as well. And so that's the idea there.
This now. They've had to build up a team of 11 people.
Right, exactly. I mean,
wow.
Right, you're not going to just be doing a 3-person coding
produced.
team, right? It's going to be
right.
manufacturing and quality, and Yeah, there's a lot of stuff there, and so they're talking about testing and setting up jigs and the realities of having it, and it's a very good post about all of the things you have to work through, and it strikes me both from the of course you need to do this, but then also feeling bad for them having to do all this stuff, you know what I mean? And this is a relatively, it's not a simple product because there's RF involved and everything else, but it is an Arduino based platform, so it's not like there's an FPGA on board and a high end Freescale or Intel or anything like that. So there is still some level of comprehension there, right? But it's like there's still a lot involved there. A lot of programming and testing and pogo pins and stuff like that. So
yeah, I know. There's tons of it. They got some good photos on there of their jigs and stuff like that.
Yeah, You just made that video about testing on panelized boards, which was that was a very good
that's
video.
just one aspect to do it. Yeah, pogo pins is the other, which I've done a video on before as well.
Yeah,
and there's many different ways to skin that testing cat. That's for sure.
Yeah. Yeah.
Choose your poison.
No joke. I guess that board you were doing, the microcurrent doesn't have any programmable parts on there.
No,
but I guess
no programmable parts. So that's one good thing in its favor,
Right. But then you could do, if it did, you could do like JTAG chain, that kind of stuff, and actually...
I could do a JTAG chain all the way through the board. That's one of the things, which I actually forgot to mention in the video, but you can do programming through the breakout of the board, so you don't have to... plug and pogo pins can be a pain in the ass, because if you've got a big panel, right, and you've got 10 or 20 boards on there, and you could have hundreds of pogo pins, and if one of them doesn't make contact,
one spring sticks, right? It's
one spring sticks, or and you've got to have multiple clamp points to clamp them down, so you spend more time clamping the bloody thing down and getting reliable pogo pins, and that's where the advantage of the video I just did, where you can route signals off your board, if that's possible, and then you can just plug in a single test connector on the side and bang. But it was for something like the microcurrent, it comes down to, how much effort do I put into it? I could fully automate the thing, but then I've got to have I've got to design a separate automated test jig that has, switching of, low-level currents for 10 different channels and all that sort of stuff.
Well, that'll be cheap, right?
Well, but the time and effort to program,
I'm saying that's not cheap. For doing low-level switching, that's not cheap. It's
no, it's not necessarily cheap.
You got relays on board. You got to make sure you're,
Yep, all your leakage currents. And
exactly, you got guard traces everywhere. Yeah,
it's not easy. So how much effort do I put in versus how many I'm going to make? I don't know how many I'm going to make. So, you sort of do a compromise. I can, save a few minutes testing here by just doing this simple thing. But, it's that diminishing returns thing sometimes. How much effort do you put in versus the reward at the end of it? And, I'd rather be working on my product and packing and shipping it than designing a test jig to test it.
Yeah. You could always go back and add in like a, programmable readback or something like that, Really throw a wrench in the works.
Oh, boy.
No,
and then, you can go to town and have, read individual serial numbers from boards and print out automated test reports. I've done that before for commercial stuff. Where you've had like an ID chip, you'd use one of those
like
Dallas
unique
Maxim ID, one of those unique, laser ID chips. So each board has its own ID, and you have automated software which reads that, and then you can associate a test report with that individual board, and serious
which
business.
Is great for troubleshooting too, by the way.
When
and
you don't have sales support, your board doesn't work. Well, look, here's a report that says it worked when it left the factory, so you blew it up, arsehole.
You blew it up, or call UPS, one of the two.
Right.
That's a lot. There's a lot of stuff in there. And so like that. That's why it's good that there are these workshops here. For working on a lot of this kind of stuff, and it's not just testing either, right? It's also just the getting the damn things built. I know. I've been thinking about this lately because I've been dealing with some manufacturing stuff, and going from there's a lot of stuff that people know about, right? With like the you have schematic, you have a board that you usually translate into Gerbers that you send off to the fab house, right? And those two things exist in time, right? So you're at Rev A of your schematic, Rev A of your layout, right? And sometimes they get decoupled where your layout might change, but your schematic might not. But then there's other layers there too where you have population options, you have different parts that you could populate, right? If you have pin compatible parts in there.
Yep.
And so I asked a question on Reddit today about that because, it just seems so messy that all of this stuff, at least in the experience I've always had, it's always gone down to like spreadsheets. It's always like the lowest common denominator of information is, spreadsheets of, if you have an Atmega 328 and I need 2 of them on my board and here's the reference designators U1 and U2, right? And it's like the lowest common denominator of information there is a spreadsheet, but probably not the best way of doing it because you can have, just different levels of assembly versus your,
there's different types. I'm still doing my stuff with spreadsheets, right? So I'm manually entering all the spreadsheets, finding the codes on DigiKey, cutting and pasting in the spreadsheets. But then I have different type of spreadsheets. One will be a production BOM spreadsheet. Another one will be, one that's designed for, hand assembly short runs and stuff like that because there'll be different parts. I'll be buying on real, cut tape instead of reels and,
Yeah, right, because then that's different part numbers too, right? That's just annoying.
And then how do you get the pricing for all that? There's one part I need to buy 1,000 of minimum quantity, and how does that factor into?
Right.
But I only want to do a run of 100. Well,
right.
How do you amortize the cost?
And the other thing I was saying in there too is that like, so my perfect world, I think, and I asked this on Reddit, and there's some good responses here as well. About how people save this stuff. At least the way I've been doing it for contextual electronics, which I actually really like. Is first off, I really am liking GitHub. I think it's a great way to track stuff because it's very trackable from version to version. It's not version 1, version 2. It's like, save date 1, save date 2, and here's the difference between the two. But I think what I've come down on is actually using your schematic as a control document, which a lot of people don't like because you think about like, okay, so I have a 0 ohm resistor that I do or don't want to populate that, enables different parts of the circuit, right? Well, I have to go in and then change the schematic or an attribute in the schematic that then propagates through to the final assembly, right? Well, that doesn't work in most situations because your purchasing department or your CM is not going to go and open up a schematic. They want, does it get populated or not? Well, who knows? But my assertion is if you have it in the schematic, if you have a attribute in your schematic that says populate or don't populate, you can then programmatically generate a spreadsheet afterwards and use that.
Well, that's how the more advanced tools like Altium work. Ideally, how they want you to do it is, everything goes into the schematic. You've got all the part number information, supplier information,
right? Huge libraries,
whether or not it's populated, into these massive schematic libraries, and it's all in there. And then you push that forward to your, to generate your BOM. All your, various BOMs and different templates and all sorts of stuff from that. So, but there's just,
it's messy though, right?
Unless you commit 100% to doing it that way, it doesn't work.
Right. Well, and so that's part of the reason I've been thinking about it too, is because, I've thought, okay, that's probably the best way to do it in terms of like logistics and stuff like that until you have a purchasing department or something like that, because then you have a purchasing person who has to either go into the program or have, a separate license to that program and have some way of, editing the library and updating on-hand quantities and all that other crap, right? Now, granted, KiCad fixes that because you don't have to pay for another seat then, but it's still a mess, right? But that's kind of why I was thinking about it like that. And it's, I don't know, man. It's still a tough problem to solve. I don't know if it's been solved yet. But,
no, and there's just so many variables involved. Everyone, there's no one right way to do it. Right. In fact, it's just more important to be consistent in what you do than to do it a right way.
Yeah,
in quote marks, right?
And to check your work. That's the other one.
Yeah, exactly. Checking your own work's impossible. Number. It's like,
well, have a good friend to check your work. How about that, right?
Yeah, well, that. Murphy will get you every time.
Yeah,
I'm convinced of it.
Well, I do like that. some other people on here were talking about, making copies of the entire project and then, saving Rev 1, Rev 2, like entire zipped up folders. That's one way of doing it.
I do that. Yep.
Yeah. And that's kind of like that's kind of like what GitHub does, except it it doesn't save everything because it just shows what's different.
Right.
Yeah, and versioning, having different but man, that's a tough problem. And so this kind of stuff, it ends up biting people like the Pinocchio guys or really anyone in a hardware startup dealing with that, not only dealing with that in terms of how do you keep track of that across revisions and, different hardware versions versus software versions, everything else like that. But then also, they're trying to save money, so they go to China, and it's just like, oof.
And then they try and think they can hand it off to someone. Yeah, we've talked endlessly about that.
Yeah.
Doesn't work. Yep. Well, it can work, but, you only hear the success stories, Oh, yeah, I just gave it to China and everything happened,
Right, yeah.
Yeah, what about the 100 that didn't, and just failed miserably?
Or the buckets of money you had to hand over that actually fixed it, right?
Yeah,
That's
exactly.
That's usually what it comes down to is the buckets of money.
Yes, and you had to hire people on the ground over there,
Yeah.
Yeah.
I wanted to ask you about your video real quick. So Dave made a video that was really good about running traces, like he mentioned, off the
board,
panel.
Yeah, off the panel. Yep. Through the little breakout tabs.
Yeah, the breakout tabs. So then would those signals be exposed then, or how are you going to deal with that? I don't know if you talked about that in your video.
Well, yeah, they're exposed. I mean, they've physically got to run across that breakout tab, and then you cut the breakout tab with your, your cutters or
diagonals,
or whatever tool you're using. As a proper depanelization tool, like a little nibbler thing to, cut these tabs out. But yeah, you're shearing through that trace. And that's just the way it is. There's no way to avoid that, really.
So do you think you'd seal that up or something though, or like a dab of clear acrylic?
No, you generally wouldn't seal it. No, you would just leave it. You just leave it. But that's the thing. Because you've got a mechanical shearing process, you can't have traces right next to each other. You can't always guarantee that they're not going to be shorted together. Because the nibbler tool might just jam those two traces together, and oops, they're shorted out. So and then we haven't even got into the electrical signal integrity aspects of routing signals off the board either. You've got to be careful there as well. If you've got any critical signals, you can't have these just antennas just hanging off the side of your board somewhere,
right.
Yeah, so that can be a big deal. And
so limited situations, or else you have to go to a more complicated complicated, like flying probe setup or anything like that.
Well, a flying probe or pogo pins or something like that. When you're talking signal integrity, pogo pins can be better, but they can be a pain in the ass too, because then they've got to go. The signal's got to go through the long pin. If you're trying to probe if you're trying to probe a USB 3.0 socket, for example, well, good luck, getting full data rate on that. You're better off. Right. You might be better off just plugging the cable in. Taking that man-hour hit. Yeah. In terms of testing, physically plug in a cable, because you just can't pogo pin a 3 gig signal or something, Well, you can. There are technologies to do that. But, expensive.
Buckets of money,
yes. Price, you can't afford it. Yeah, exactly.
Buckets of money.
And there's lots of revisions to get it right and all that sort of stuff. So,
yeah.
But no, this technique of routing the signals through your breakout tabs and stuff like that off your board, it can be very handy. Because as we mentioned before, getting a whole bed of pogo pins is not easy.
And those things are
not
expensive.
Very reliable.
They're expensive little things.
They're
they're all gold coated and everything.
$2 each. Oh yeah.
Ugh. Yeah.
No, if you've got hundreds of them, you jig and then you've got to replace them. There are, they do wear out and stuff like that. Whereas if you've got a but, often, and it might be more sensible to have your pogo, still use pogo pins, but having them on, on one side of your panel instead of under your board. Because if your board's a very dense board, you may not have room for test pads, for example. You've got a really tight layout on your board, and shit, I can't afford room for test pads.
Right, and you never plan from up front. You're always at the end, you're we should have put in test pads.
It's pads. And then you try and get the pogo pins on the end of your 0402 resistor, and they just fall off. You've got to use the right head, like a crown one to sort of catch, and they just fall off, and it's just... it's ugly, and they short out the component next to it because you've got such a dense board. You just can't, do it. It's just, Yeah, it's a world of hurt. It really is. But that works if, as you said, if you forgot to include test functionality, like this mob we're talking about who found that, oh shit, we have to test our boards, and you didn't plan that into your design, then it's a good fallback position. Just build a test jig with pogo pins on the bottom, and hopefully you can get it working reliably enough to test your run of 10,000 boards.
Only 10,000. It's no big deal. You'll get through it.
No. And then there's the stuff about bad contacts and things, not only on pogo pins but on test connectors, because I mentioned in the video that you have to design into your test jig to make it easy to replace your test connector, because it's only going to have a finite number of cycles. The PCI connector I used, for example, in one design, that's only 500 cycles or something.
Right. Yeah. Depending on how much gold you get and everything like that.
Yeah.
Right?
Yeah. You could pay 5 times the price for the connector because it's got double the amount of gold on it.
30
microinches. The amount of gold. Yeah.
2,000 insertions.
Yeah. That's right. But you don't. Price. Yeah. But then the data sheet might say 2,000. Right, but in my experience, no, because you're forcing the board in at different angles and stuff like that.
Yeah.
That's just a theoretical, limit. But when you've got jigs, that's, slide boards in, or people are inserting them by hand, which is even worse. They don't always go in vertically, they go into angles, and that can ruin the connector. They don't always go in gently. No, slam, you've seen these production operators, shit, it's, 10 to 5 on a Friday afternoon, wham!
There's beer to be drank.
Or the night shift, even worse,
Oh, yeah, I used to be on the night shift.
Oh, yeah.
We were terrible.
I know. You bastards.
Yep.
Guys like me who had to come in the next day and fix all the shit
what
that the night shift ruined.
Gamble!
Worst is night shift on a weekend. You come in Monday morning and all the test jigs are just broken.
Yep.
Just have to spend all the Monday fixing the bloody test jigs.
I think a good rule of thumb too. I remember reading about like startups and stuff like that, and some good advice I read was for software startups where they're like, get used to being like, you can prove out ideas by being like the human machine, like the man behind the curtain, and like operating stuff and faking it like that. And I think the parallel for hardware is get ready to just be sitting there and doing your own testing. If you're the designer, you might be in for some drudgery. Like testing and plugging and unplugging and soldering single resistors on 100 different boards and stuff like that, and just find a good podcast.
And be prepared to do that right when it comes off the end of the line too. Because a big thing is you don't want to push that button, run in 500 or 1,000 panels through the SMD machine. You want to once they've got that machine set up, you want run one panel through, please, and you stand at the end of the line and you take it off. Ouch, it's hot. And then you start testing it. Is it okay? And then you've got to give the nervous thumbs up for run the 1,000 panels.
Okay,
through,
enough. Yeah,
exactly. And then you cross your fingers and hope. Well,
hope you're not there till Kingdom Come for soldering single resistors. And oh, is that dialed backwards? Oh, I forgot.
Because if they load the wrong part in backwards on the loader, on the feeder of the machine, and you push the button on 1,000, well, it might be their fault, but when you've got to ship boards to your customers, well, it's ultimately your problem. So
yeah, that's where manufacturing is very unforgiving for personal lives sometimes. There is no... Yeah. I think.
Have you ever tried to extract a penalty out of a contract manufacturer? Like, oh, you screwed this up. You owe us money, and like, oh, it's just...
Have you?
No.
Have you tried to do it?
Yeah, it's not nice,
Downhill battle.
At best, trying to extract money back out of them is next to impossible. At best, they'll go, look, we'll fix it, and then they'll go, yeah, we'll fix it in our own time, and we'll take a week to to rip off all that part and resolder them back on.
Right, poorly.
Bingo, your schedule's just blown out by a week or two.
Yeah.
And you can't charge them penalties for, loss of business because, your customers are waiting, loss of reputation and all that sort of stuff. It's just...
Right. Yeah, that's always the problem with people you got to keep working with, too. Like, it's like you want them still to build the next 10,000 boards, so you can't be like, yeah, you're fired. Yeah. It's like, we're angry.
Exactly. It's all words in the end.
Yeah.
Well, yeah, because in the end, the only thing you've got over them is the fact that you won't give them any more business. But often you're locked into them and you've invested so much money and time in getting them. You can't just switch contract manufacturers like that.
And if you're doing anything right, you're probably squeezing them for price anyways. And it's like, well,
yeah, that's right.
Yeah, that's a bad business to be in.
It's a dirty dance that you got to do back and forth, and it's just yep. For some reason, we keep doing it.
Yeah, well, we have to.
We have
that's
to.
where benefits of automation go both ways, right? I mean, like if you have more automation, then you can try and reduce it. Basically, with more automation, it's just more likely that I'm going to be the one with the mistakes instead of them.
Right. Okay.
Which I luckily do all the time, anyways. So yeah, yeah. Thank God for second reps.
Oh boy. And even on simple designs, like my microcurrent's the simplest thing you can get. I'm going to goof something up on this board. There's probably going to be something goofed at the contract manufacturer, even though there's only 10 parts on the board. I mean, man,
it's tough.
Yeah,
that's why you got to have friends check over your stuff and hope for the best.
Oh boy. No, you just have to assume that there's going to be an issue and you're going to have to respin that board. You're going to have to pay another couple $100, get a new panel made, and scrap those and
tooling costs,
build up a new one. Yep, exactly. It's you've got to amortize that cost into your project.
That's the cost of stupidity.
Exactly.
Or carelessness is probably a nicer way to say it. Speaking of your, go ahead.
No, go.
Speaking of your microcurrent, though, did you see this chip of the week I put on the list today?
No. What have you put on chip of the week?
It's not a chip. It's a resistor.
Oh, the resistor. Yes, I have seen this.
So these actually aren't like super new, but they're. I think they're for the through-hole side of things. Actually, I think that's actually because I know I've seen these on surface mount before, but they're Z-foil resistors from Vichy, and they're awesome.
Well, they're the world leader in high precision resistors. Yeah,
I know.
These are. Well, yeah. The killer here is not the tolerance, right? Like the stability, 0.01%. Whoop-de-doo. I've got a box here with 0.005% in them,
right?
And they only cost $20.
It's the TCR.
It's the TCR, the temperature coefficient, right? And it's 0.05 ppm per degree C.
Yeah,
holy shit!
Up to 60, but that's insane. That's
Yep. and that's what it's all about here. It's all about the Tempco. It's not necessarily about the absolute accuracy. As I said, you can have a 2%. Well, drift in time and temperature.
Yeah, right. Yep.
That's it. That's the big. Well, the thing I haven't read all of this, but they're claiming it's a noise-free design. How are they claiming that? Like it's what? There's no Johnson noise in it. What the hell are they on about?
Well, this
we are reading. They're talking about audio, folks.
Copy
they're
right
talking
now,
about
so yeah,
we are reading marketing copy.
Yeah, that's
it's written specifically for the audio market. These things are designed for, right?
Right.
So we're automatically getting into the wank area here, and they've got low microphonic noise. Generally, microphonic noise isn't a huge deal in resistors. It's more a big deal in multi-layer ceramic capacitors, as we've mentioned before, and other types of caps. But it does happen in the resistors as well. But geez, there's a very narrow
I didn't see the prices on these things.
Going to worry in that.
I've looked at the price on the surface mount ones before.
I haven't seen the prices. How much are these?
They're like I haven't seen on these, but on the surface mount ones before they're like 10 plus kind of bucks, I think. I mean, like they're
oh well, that's not it's nothing. You buy one off DigiKey, 20, 50 bucks.
I don't
for
mean
a precision
in one quantity though either. Like these are
right.
These are
well, my new microcurrent uses a $12 resistor on it.
$12, huh? Yeah.
Mm-hmm.
What's the specs on that
$12. 10 milliohms, 0.1%.
Oh.
Because it's 10 milliohms. So when you get that low to get precision, like my previous one was 0.5%, right? Whereas I'm getting, 5 times better. I'm now going down to 0.1%, and the difference in price is, 10 times.
Right, exactly. And it's still low quantity, relatively, right?
Yeah, and it's still relatively low quantity. But even you buy a reel of 1,000, they're $6 each. I mean,
Wow, that's insane.
Oh yeah,
that's not a reel you want to lose in your closet there, right?
No, exactly.
you know exactly where that reel is.
The most expensive part on the board is a resistor.
Yeah. Well, and you know what you're really paying for there, though, too? I mean, I'm telling you, the listeners, of course, not you. I know you know what you're paying for. You're paying for not calibrating at that point, right? So
I'm paying for not calibrating it, yeah. I could use a regular one and have a trim pot and tweak it, but that costs money, you know, and effort and pain, and I just,
and
don't
drift, because those little resistors drift like crazy.
Exactly.
And then it costs. So, that's silly. So yeah,
generally you don't have to worry too much about that, because you can buy a low drift resistor like this and then put in one of the trimmer caps, but generally the value of the trimmer cap is so small that it can have a much higher Temco, like, by a couple of orders of magnitude, and it still doesn't affect the temperature coefficient of the main resistor, because it's a percentage of. So that's how it works.
Right. So it's just like a 100 ohm sensor resistor and like a 1 ohm trimmer kind of thing.
Yeah, exactly. So you can have a 100 so you can have a 100 ppm 10-turn trimmer resistor on a 1 ppm 1K resistor, for example, and it's yep.
I
am not paying for the calibration. That's what I'm paying. I'm paying for the absolute value,
and that's nice.
And,
that is
and
a nice
a low
thing to
Temco.
have.
Oh no, it's good. Yep.
Yeah.
I can't imagine anything worse than having to tweak the calibration of each microcurrent.
I can tell you what, it would be putting a DAC on board and doing it with programmatically, or putting a programmable resistor, and then having to add all the backbone for that,
Yep, it probably would. Exactly. Yeah. And then there's another world of hurt and expense and getting all that set up. Yeah,
that's the downside. I mean, I love like precision applications, obviously, having my past in it, but it ain't cheap.
Precision does not come cheap.
Right. That's why even the best, if you look at the best low cost meters and stuff like that, it's still, there's always something in there. It's always.
And trimmers, trimmers don't instill. Well, they can instill confidence in you. Oh, because look, it's been tweaked to the value, but then you start getting paranoid. Oh no, it's got a trimmer in it. What if that's drifted? What if that's not set correctly anymore? Things drifted. So it instills a sense of confidence and paranoia at the same time.
Well, I think it kind of shifts the burden too onto like, so say you're selling the microcurrent to someone, and you say, okay, this guy just, it's decent resistor. You got a trimmer in there. You got to adjust it once. It's on a 1 year cal cycle. You got to change it every year, or you got to do it every year. Well, then now the burden's on your users to find a solid source that they can compare it against, right? Because that's all calibration is having everything referred back to a single, really, 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 really good reference. That's the expensive part, right? I mean, that's even what these manufacturers are doing. They're comparing it back to some NIST. Reference, is it NIST? That's right. Yeah.
NIST. Yep.
Yeah.
So that's why I choose to use precision. Often, I've done many precision projects like this, and I almost always choose to pay extra for the precision component, so then you just don't have to worry about the trimming.
Yep. Well, and then the burden's on you not to mess it up by putting in a crappy op amp or something like that.
Well, it's exactly. But as I've done a video on before, one of my this is a couple of years back now, and I was making microcurrents. I got shipped the wrong parts from DigiKey. It was the exact same resistor, but they goofed up the part number, but it was 1% tolerance instead of 0.1.
Oh, jeez.
And I didn't know that until they were manufactured onto the board, and I started testing them, and I had a high percentage. I had 30% failure rate, and I'm going, what's going on here?
Right.
And I traced it down to, DigiKey had a reel labeled wrong in there.
That's insane.
Yeah, I know.
You know what you should have done? You should have insisted that you buy something through Amazon instead, and it could have been delivered,
by quadcopter in 30 minutes. Yes. Yeah.
Come on, DigiKey. Where are you? Come on, DigiKey. Where's the drone delivery?
We'll have to close the show out with this.
It's ridiculous. This is a publicity stunt. This is publicity stunt like crazy. This is a sillier mode of transportation than the Sinclair C5.
Right.
As much as I wanted the Tacocopter to be a real thing, and as much as I think that it could be a possibility someday, it's like, this is stupid. This is
Well,
stupid.
That's the thing. That's what it has, that air of possibility, no pun intended.
Yeah.
Right? And they've demonstrated it working. Other people have demonstrated this. I think there's an Australian company they want to deliver pizza by.
Yeah, right.
Quadcopter or something. In theory, it's one of those, in theory, it's possible, and in controlled practices, it's possible. But
it's the world, and it's messy.
But, it's the world. What are you going to... I was just thinking before the show, looking at this, that they would have to have some sort of algorithm in the quadcopters that they all, at a random height or something like that, because they can't all follow, they can program to follow different paths, but then if you've got 100 different companies all offering these quadcopter services, they're all got to stay below the, what is it, the aviation limit or whatever, the 400 foot. So they've got to all do that. So they all have to run at random heights so they don't run into each other.
Yeah.
And and you've got the sky. And have you heard how loud these things are?
I know. Yeah.
You've got a whole sky full of these things.
Right.
Oh, come on. It's just...
Well, and that's the thing. I mean, like all of this kind of technology stuff, when it hits the real world, it turns into a political issue. It turns into a regulatory issue, that kind of stuff. And that's when it gets really messy, right? Yeah. And it's like... I was talking to my dad actually over Thanksgiving, which was the holiday here in the States recently, and we were talking about getting older and stuff like that. And basically, I was joking with him like about when I'm going to pull his license. He's not that old, but I'm like, we're just talking about retirement and stuff like that. And then I thought about it, and I'm like, Dad, we're not going to actually have to. As long as regulation doesn't get in the way with as long as it goes well as it can go, there's a very real possibility that old people, in 20 years will not be driving themselves, right? Just like, going to the post office could potentially be removed with the drone delivery, that kind of thing. And so it's basically technology hitting the reality of the real world and trying to make it reality, It's just...
And there's technical issues in there as well. Like, like cities are quite large. I don't know about Cleveland there, but Sydney is like 50 kilometres wide. And you're only going to have one distribution point, right, where all these quadcopters are swarming, flying out of. And then they've got to go at least, possibly 25 kilometres and back. And, in theory, it's possible, but... like if you get a tailwind up, if you get a headwind, like your quadcopter's just going to fall from the sky. It's just going to be bullshit.
Right. Also, the weather in Cleveland can be a little nasty, so it's like you're not going to just not deliver. It's like UPS guy and the FedEx guy still comes around when it's snowing, but can a quadcopter do that? It's like, I don't know.
Have you seen how shit quadcopters are in the wind? They just get blown ass overhead, right? Yeah, breath of wind.
Yeah,
come on,
whatever. It's press. I think that's all it is right now. So,
but I have no doubt Amazon are thinking about it, but that doesn't mean it's practical, right? Just because it's Amazon and they've got a shitload of money,
right?
And they've probably got people working on this just because, Jeff Bezos, whoever the bloody CEO is, it's his pet little project, and he wants to have a bit of a wank with it. Yeah, exactly, exactly. And he can have a wank any way he likes.
It's fun to like blue sky these ideas like that. Again,
yeah, of course,
no pun intended. But it's also interesting, because there is some futuristic stuff at Amazon specifically going on already that I think is much more promising, like the Kiva system stuff, where the robotics.
What's that?
That's the robotics that bring the shelves over to pick and pack people. Pick and pack people.
Oh, that's been going on for 20, 30 years, automated factories that have pick and place stuff from the shelves, there's nothing new there.
What do they bring the entire shelves over? That was what the Kiva Systems thing is. So they actually had these low profile robots that lift the shelves up.
Whether or not you bring individual products or bring whole shelves, there's no difference really.
Well, maybe. I think, but either way, but they have practical robotics in a mixed human robotic environment, and I think that is very interesting right now. That's happening right now. That's actually delivering stuff, and that's an interesting thing for right now. And this stuff, maybe it's a possibility, but it's at it has just begun its life into the long hype cycle. Life curve, right? It's just on the ramp up, and we'll hear about it for a couple more years, and then maybe they'll do it, and then if it ever does, then it'll ramp back up in popularity, or however the hype curve works, or hype cycle. So,
was I the only one who had the stereotypical vision of gun-toting Yanks sitting on their front porch. Get out of my airspace and shoot the things down with their shotgun, right?
Yeah.
Was I the only one thinking that when I saw this?
Probably not the only one, but
right.
I'm sure you laughed a little harder than most.
Yeah. Get off my lawn.
Yeah.
In
Clint
Clint
Eastwood style.
accent. Yeah.
Yeah, Gran Torino. Yeah, maybe.
I don't know, but it's just there's so many issues here that may never be solvable.
That's all right.
Unless we get hoverboards, which are going to happen in 2015 anyway. So
Right. Well, we only got 2 more years for that, so we might as well focus on that now, folks.
No, I think it's a bad investment. These quadcopters, hoverboards.
Right. Seriously.
The action's going to be out.
Come on, Bezos.
Yep.
I guess there's only 2 more things to talk about. First off, congratulations to you, 100,000 subscribers.
Oh, right, 100,000
Very
subscribers.
exciting.
Thank you very much.
YouTube.
Absolute bullshit number,
Of
so
course.
it's just an arbitrary round number, whoop-de-doo.
Right.
Yeah.
And then the other thing was, I was going to mention today that we should try and have a hiatus on saying Kickstarter. I think we said it a couple times. So we didn't succeed there. But the reason we should have said, I was going to say hiatus because it was going to be really funny when I announced our guest for next week, which is a bit of a Kickstarter success here. I mean, you might have heard of the project. It's kind of a big thing. You know who it is, Dave?
Tell him.
It's Andrew Whitty from Pebble. It is the CTO of Pebble will be on. I hope I'm saying his name right. Is Whitty. But he will be on the Amp Hour next week, and so we'll talk to him. He obviously he's worked with Dragon Innovations, Scott Miller, who we talked about, and who's been on the show in the past, and one of our listeners was nice enough to introduce us to him. So he's going to be on the show next week, and we'll be talking about the biggest Kickstarter in history and a very cool product, and one that Dave had interest in because he's a watch enthusiast.
I'm into do-it-yourself watches, and they were 12 months behind, I think, on their delivery, weren't they?
12?
Or something enormous.
Well,
I don't know. They were, it took a lot longer.
There was a lot of hurdles there, and we will be able to talk about them.
there were a lot of hurdles, and that's what so get your questions in.
Yeah.
And we can't have a hiatus on Kickstarter because I'm going to do a Kickstarter for the microcurrent soon.
Well, that's another reason to not talk about it this show, so we can talk about it in the future shows,
Right.
And we talked about it all last week, too, so, yeah.
Yeah. So
we talked about a lot of electronics this week.
Crowdfunding.
Even though we said we wouldn't, we talked about a lot of electronics, so bonus.
Just because you had a big boner for the
this kit?
TI
Yeah. Oh,
kit.
man.
Yeah.
Wait till you see pictures. Oh.
Folks.
Yeah. All right, well, get your questions in, and we'll talk to you next week.
See ya.